Hi there, welcome to this spicy question video where I'm looking to answer some of the most challenging questions I've seen on GCSE Maths in recent years. This one has come up from a recent past paper I've done with my Year 11 class. Every time I see this question, I think, I really can't remember what I have to do here, and I thought it's time I confront it and really give it a good go. And this might be one of the very hardest questions I've seen in recent years. It's really quite tough. So yeah, it's from Edexcel paper 1. So that means that this question was designed to be answered without a calculator, which does make life a little bit more awkward. Yeah, it's question 22. It was the last question in the paper. There it is on the left. What I'll do is so if you feel like you might want to give this question a go without any prompting, now's a good time to pause and see if you can give it a go. And what I'll do is, on this screen, give you a few hints along the way. So before I actually answer this question, then I'll show you what I'm thinking. I think it's really tempting to just sort of leap into a question, but there are often hints in questions about what you need to do. Okay, so let's just have a look. So we've got two congruent parallelograms. So these two, same thing. I guess that gives me a few indicators. It tells me that I've got lots of sides that are equal in size. So those A, B, and BC, and FE and ED, they're all the same. This line A to F is the same size as B to E, the same size as C to D. Okay, so you might want to think about things at the same size. Okay, that's one thing. The next thing that this tells us that is of note is angle ABC is 30. Now, you do need to be familiar with exact trig values, particularly like sine 30 is 1/2, and the cosine of 30 is √3/2. If you need a refresher, now's a good time to remind yourself, but those two things might be useful here, and that's why this is okay that it's in a non-calculator exam. We've got that hint. The next thing that is of note, I suppose, is the fact that I'm being asked to show cos PBQ. There we go, cos PBQ. And hard questions might involve the cosine rule. So there we go. That's what I'm thinking. So I'm looking to exploit this congruency and exploit some symmetry in this question. I'm looking to use exact trig values, and I'm also maybe going to expect to be using the cosine rule. Get stuck into this question, so it's slightly smaller here, but I think I'm going to need the space to work through. I normally would just talk through these questions live, but I always get stuck in this question, so I had a go at this before recording the video, so fingers crossed that I'll be able to reproduce my result. Okay, so first thing I'm going to look at is, first of all, what is PBQ? So I'm looking to show a result about PBQ. That is, if I draw a line from P to B at the top to Q, that's a pretty rubbish line, like this angle here. So I'm going to give that a label theta. So let's say first of all that PBQ is theta, because I'm not sure I love referring to things by a 3-letter name when I can just give them one. Okay. The next thing to think about is I've got information about ABC. So ABC is 30. Now this diagram's getting quite crowded, so I'm going to draw that out separately. So I've got A, B, C, and then this angle ABC is 30 degrees. Well, so I'm also told that the length A to B is x and the length B to C is also x. Now, what I'm going to do is find the base length of this triangle, A to C, because that line on the original diagram is the same as PQ. And my plan of attack here really is to work out this purple length and then use it in the triangle that's got PQ in it. And there we go. Okay, so I'm going to use cosine rule twice. So once to find that length and then the second time to use the angle. Something may have clicked for you here and you might want to pause it and carry on. Go ahead. So yeah, here's my plan. I'm going to find the length A to C, which let's call it A, just give it a label, and then let's write out the cosine rule. So the cosine rule says that A squared equals B squared plus C squared minus 2BC cos theta, okay, or cos A. So A squared is B squared, which let's call one side B and the other side C. So it's x squared plus x squared minus 2 lots of x times x, which is x squared, cos 30. So A squared is x squared plus x squared is 2x squared. Take away 2x squared, and cos 30 is root 3 over 2. And to make my life a little bit easier, I'm going to factorize out 2x squared, and then I'm left with 1 minus root 3 over 2 for my expression for a squared. Now, it might be tempting here to square root all of that and find the value for a. I'm not going to, because it looks awkward to square root. So I'm going to leave it and hope that I can use it a bit later. Right, what I'm going to move on to now is looking at this blue triangle I started to draw. So let's draw out the blue triangle, which goes from P to B to Q. We're told in the question that BP is equal to BQ, which is 10 centimeters. So these length BP is 10 centimeters and BQ is 10 centimeters. And I just worked out, well, I didn't work out the base length, but the base length of this triangle squared is 2x squared, 1 minus root 3 over 2. So, okay, so the thing I'm looking for here is the angle of B, which is theta. So I'm going to use cosine rule again, and this time I'm going to do it like this. A squared is 10 squared plus 10 squared minus 2 lots of 10 times 10 times the cosine of theta. And well, a squared, guess what? It's this thing I just wrote down. A squared is 2x squared, 1 minus root 3 over 2, and that's equal to 10 squared plus 10 squared, that's 100 plus 100, which is 200, minus 2 lots of 10 times 10, that's 200, cos theta. Now, you might see in this expression that we've got now, then this equation, I've got a 2, I've got an x squared, I've got a root 3 over 2, I've got 200. Look what I'm trying to show. The result that we're trying to show has got root 3's in it, it's got 200's in it, it's got an x squared in it, so it's looking quite good. One thing I'll say is it's got on the numerator 2 minus root 3, and what I've got on the left hand side of my equation is 1 minus root 3 over 2, and I've got a 2 on the outside. So what I'm going to do here is expand that bracket back out before we do anything. So if I multiply the 2 into the bracket, leaving the x squared outside, I get 2 minus root 3. Okay, this looks really good. We're nearly there. Now, I want to get cos theta on one side, everything else on the other. So I'm going to add 200 cos theta to both sides. So that's going to leave me with 200 cos theta on the left. And at the same time, I'm going to subtract that rubbish x squared 2 minus root 3. Okay, so cos theta or is then 200 minus x squared 2 minus root 3 all over 200. Oh, 200. Okay, then dividing that through then, 200 divided 200 is 1. And then if I leave the rest of that stuff over a bracket, I've got minus x squared 2 minus root 3 all over 200, which is what I'm looking for. I've not quite written it in the same form, but I could take that. I mean, if we're being really picky, what this has all shown then is that cos theta, which is cos PBQ, is 1 minus 2 minus root 3 all over 200 times by x squared. That's what we wanted. Okay, that's as required. That is a really nasty question. But once you see the triangles that you need to draw, it's just cosine rule twice, and then it's just fiddly algebra. But remember, these questions are designed to stretch and challenge the most able students. So if you feel challenged by it, good. That's probably how you should feel about it. It's a nasty question, but there we go. Hope that's been an informative video for you all.